I can't go on without the camera. I think I should have, but what can you do? Good evening all, welcome and thank you so much for joining us this evening. It's terrific to see a great crowd like this, I think. Testament to the topic and to the speaker that we have tonight. My name is Andy MacKinnon. I'm a Machosen resident and part of the Machosen Biodiversity Project. And I've lived in this community for about 37 years now, and I think there cannot be a better place to sing the holly and the ivy. So please feel free to join in. The holly and the ivy, when they are both full grown, of all the trees that are in the wood, the holly wears the crown. So tonight we're going to talk about holly, with the running of the deer. Of course, the deer are running. The holly is one of the few plants in Machosen they don't like to chow down on. But it's important to recognize, I think, that almost all or all of Canada's holly, commercially, is grown on Southern Vancouver Island. And there used to be even more growers on Southern Vancouver Island, but there are, of course, or were, of course, Machosen orchards to commercially grow and sell holly across Canada. So this is a plant. We talk about it as a tree here sometimes. I don't think most people think of holly as a tree, but I'm sure Sloan will give us a few examples. And I hope people saw the trunk from the Seams property on the way in. If you really want to give yourself a hernia, try lifting that. It's extraordinarily heavy. Many of the older established orchards on Southern Vancouver Island have been abandoned, overtaken by urbanization. But still, Southern Vancouver Island grows almost all of Canada's commercial holly. So holly is kind of a love-hate crop. Tonight we're going to give you a few good reasons to hate it. I wanted to start from a position of love. This is a tree that has long been associated with solstice celebrations, with the Roman Saturnalia, where people decorated with and gave gifts of holly, which was Saturn's favorite plant. The Druidic cultures who regarded holly as being kind of an evergreen berry-bearing cousin of their beloved oak, and so incorporated it into their celebrations. And Christianity, ever the optimist, of course, picked up on all of these pre-Christian traditions and incorporated holly, we can say European and North African and Asian plant, into their celebrations worldwide. And the words of the holly and the ivy go on to detail that kind of appropriation with things like, the holly bears a berry as red as any blood, and Mary bore sweet Jesus Christ to do poor sinners good, and so forth. And of course, even the name holly is derived etymologically from the same place as holy. Right? So this is a revered plant, and yet here, in this part of the world, it should also be considered a pernicious, introduced, invasive species that has all the tools required to do an awful lot of damage to our native plant communities. It's not, in its initial decades at least, a particularly fast growing plant compared to some of our other plants, but it is dedicated, and once it's got past its initial growth stages, it begins a growth spurt, and especially a reproductive output that's really practically exponential. And a holly tree around here will live for centuries, at least 250 years. So it may be a while getting going, but once it's going, it's there for a long, long time. As well, in contrast to things like Scotch broom and a lot of our other introduced invasive species, holly is really shade tolerant, as we say in the forestry business. It's a species that will do well in the understory of a forest canopy in places that things like broom and gorse never will. They need to be on the edges or in openings or something like that. So things like holly and spurge laurel have the potential to do an awful lot of damage to our ecosystems here. They have remarkably aggressive and thirsty rooting systems. They may very well produce chemicals that will inhibit a lot of other vegetation, but I can say no more because I'll trod on the territory of tonight's speaker, Sloan Slink. Now, Sloan is a graduating student from the Restoration of Natural Systems program at the University of Victoria, earned his undergraduate degree from the University of Hawaii in earth science, and is interested in applying geology with ecological restoration by pursuing a master's degree in the spring of 2026. Over the last year and a half, he's worked in Machosen parks, conducting field work, lab work, data analysis, and he'll be publishing a paper based on his work at the end of the year. So thank you very much for joining us, and please welcome Sloan Slink.
Well, thank you, Andy, for that lovely introduction, and thank you everyone for joining me today. Yes, my name is Sloan Slink. I've been working on this restoration project for a year and a half, as mentioned. Actually, this time of year is kind of important to me because this is the time of year I started my restoration work, doing my soil tests and going into the chosen parts. So I think about that this time of year. Thank you again to Andy MacKinnon and Neil West for assistance in finding the venue. Al Murray did leave from the Machosen Community Association, but I want to say thank you to him as well for giving me this opportunity to do my presentation here. It's a delight to be able to be here and present for the public, the friends, and relations I have. So first I'd like to start with the land acknowledgement. So the Machosen Community House, as well as my project sites, which was at the Matheson Lake Provincial Park, as well as the Machosen Wilderness Park, were originally stewarded by the Lekwungen-speaking peoples, which include the Songhees and the Esquimalt nations, as well as the Shawnee First Nations or Beecher Bay First Nations. When I was doing my field work, especially, I thought about this a lot, because with restoration and working in the restoration systems at UVic, I learned a lot about the importance of thinking about reconciliation with restoration work. And I think that when we're stepping into thinking about any restoration works that we want to do, we need to be thinking about the traditional use of the land, as well as the original people who were here stewarding the land, and what we owe to bringing these places to health again. This is just a quick introduction of people who have helped me along the way. So we have, first I want to mention thank you to Habitat Conservation Trust Foundation for covering the cost of the venue. So no donations are needed, it was totally covered, as well through MISC for providing the opportunity, which is a Machosen Invasive Species Cooperative. A lot of people to mention, we have Nancy Shackelford, who's the Assistant Professor and Director in the Restoration of Natural Systems program, who provided me the chance to meet Neil West, who was the one to coordinate this research opportunity. Thank you to Neil West and to Brenda West for providing this project idea, as well as a lot of research background and in-person experience that I don't have since I've worked with it for about 10 years. As well, thank you to Brooke Hayes, who's an eco-gastronomy division at the University of Victoria, as well as a PhD student, for providing me opportunity to work in the labs and learn how to process soil for a lot of my research, as well as Chief Administrative Officer Bob Payette from the Shawnee First Nations coordinator, who was able to speak with them when I was looking for approval in working on the traditional lands. To Stephen Businger, who's a professor of atmospheric sciences at the University of Hawaii, for looking over my presentation, as well as helping me with reorganizing my publication. Tina Hansen, who's a deputy corporate officer within Machosen, for coordinating permits, because I did need to get permits for working in the parks, and many other people. So today I'm speaking about the impacts of invasive English holly on soil chemistry and biodiversity, focused on Southern Vancouver Island. The scientific name of English holly is aquifolium, and this was in completion of my certificate of restoration at the University of Victoria. So first, just to get a sense of place, we are in a biogeoclimatic zone called the Coastal Douglas Fir biogeoclimatic zone. So it is a relatively limited biogeoclimatic zone that harbors 100 unique species, ranging from different types of shrubs, trees, vines, mosses, and herbs. These are native species that have evolved to fit these soil conditions and this climate. And something that I think about when people ask me the importance of restoration, or what is the value, and I think that a lot of the value comes from these are special places that have evolved over many hundreds of thousands of years, and unique species have evolved here. And by harming their basic underlying structure, you're creating like a cascading effect for the rest of the ecosystem. So it is a relatively small area, but it needs to be protected even more so. So restoration was definitely my major project motivation, because that is my interest in school. As mentioned, it was 1.5 years of working, which included doing field work, doing lots of research, communicating with members of the community, as well as doing a lot of lab work. The most rewarding part was definitely the 6 months when I was working in the parks, because Matheson Lake Regional Park and Machosen Wilderness Park are just such beautiful places. And definitely seeing the impact of English holly, especially in Machosen Wilderness Park, where I'll go into a little bit more, but those are sites where English holly has been treated, and you see a lot of these dead zones. It is quite shocking, because these are parks that seem otherwise untouched and are old growth parks. So it definitely is noticeable, and I do recommend folks who enjoy hiking in the area to visit the sites and have a look at it yourself. So I will just, this is my hypothesis. When I was, after doing my research and speaking with people, this is what I was looking to see if it is true or not, which is that invasive English holly alters soil chemistry and physical properties underneath tree canopy drip lines, so specifically under the canopy drip line, affecting native ecosystem health and integrity. So this we will see in some images shortly. Just to make sure we're all on the same page, English holly, this is a photo of English holly that someone has on their property. This is a very large female holly tree. The plant is a perennial tree or shrub. It can range in size, but it can reach up to 15 meters in maturity. A couple identifiable features it has are its leaves, which are spiny, waxy, and they also have, the trunk itself can form either a single trunk or a multi-stem sort of thicket. It is a dioecious plant, so that means it has a male and female species, plant separate. The females will be producing red berries. Berries themselves contain saponin, which is a toxin to humans, pets, and livestock. It's a very minor amount, but it is notable. They also produce white flowers on both female and male plants. They are very common decorative plants, and they are often used, as Andy mentioned, common for holiday decorations in the winter. So English holly is found along British Columbia, California, Oregon, Washington. These are some areas along the coast that it thrives just as an invasive species. It is also found in other parts of the U.S., such as Hawaii. And by the Invasive Species Council of Metro Vancouver, it is considered one of the 12 most problematic invasives that we have. Something interesting about holly, when doing my research on how you could potentially manage it, it is a very difficult plant to manage because of how hardy it is. Grazing doesn't work because it regrows, as well as the toxicity you have to consider. Burning is also quite dangerous because the leaves are flammable and it will regrow. Mowing and brush cutting is also ineffective. You pretty much have to remove the tree if it is a full tree by the root, or you need to treat it in order for you to completely kill the plant. It is often misidentified with Oregon grape or Mahonia versus, so I'll just show some images so we can see the difference between the two. So on this side here we have English holly. And this is at a sapling size. So the main difference is English holly has red berries and Oregon grape will have blue berries. But holly leaves have single individual leaves attached to the stem. They are thicker and waxier than Oregon grape leaves. If you were to touch them, you would be able to certainly feel a difference. And Oregon grape leaves have a pinnate leaf form, so the leaves grow parallel to each other. So initial observations when I was visiting the parks with Neil West and Brenda West was the dead zones. So these are spots underneath the tree where it seems that there's little to no plant growth. I keep talking about it, but I will show images soon. And that I think is the first thing that is the most noticeable, just because it's so visually shocking when you are in old growth forests. As well, it is as an invasive species, looking at a variety of research, I did find invasive species often do change soil chemistry. I think that based on my research, it's probably done through root and leaf exudation for English holly, which is the way that the plant actually can interact with the soil and produce chemicals through leaf and roots, which is supported by the novel weapons hypothesis, which states that invasive plants gain competitive advantage over native plants by releasing chemical compounds not found in the soil, altering native plant communities and ecosystem function as a whole. So why should we be concerned about English holly? We have a lot of invasive species to be concerned about, so what makes this one something that is important to be speaking about today? Now, this is an image of the dead zones I've been speaking of. This was taken by Brenda West. This is a treated site. So this is one of the sites that I visited and did soil tests and to do pH tests and do teabag tests, which I'll talk about later. So this is, I think, a very interesting site. It's a treated site, so this tree has been dead for 2 years, and still around it we have what seems to look like a dead zone, where nothing is really growing. You may have some mosses like Convergia oregana growing on the surface, mostly tending to be growing on leaf litter or on logs. But other than that, it continually, you do see these spaces where there's nothing much growing underneath. So this happened under living trees, it happened under treated sites. A research done by Stokes and colleagues in 2014 found that about 79% under cover, where English holly canopy was covering, was devoid of native evergreen and woody vegetation. So this would lead you to believe there must be something happening in the soil, because even after the tree is gone, you wouldn't be able to say in this case, well, there's no light reaching it, because it has been 2 years of opportunity for plants to sprout. But there continued to seem that nothing was really coming back. Invasive species that alter soil chemistry are a particular concern, just because they can, even if you remove them, you don't really know how long the soil may have been altered and what it takes for it to be returned to an original state that native plants can grow. So another thing to be concerned about is the woody invasive growth pattern. So this isn't specific to English holly, but this is a trait that is found in a lot of different types of woody invasive plants. It is separated into two phases. There's the lag phase, which I will talk about first. So the lag phase, a species is introduced to a site. It spreads, in this case with holly, we have seed dispersal and we have the suckering where the plant can actually grow out. Initially the spread may be a little slow. It can last upwards of 10 years where it doesn't really look like anything is catching on. The plant is just spreading out relatively normally. Typically you don't have any big thickets forming with English holly at the time, so nothing seems very alarming. And so that's the lag phase there. The next phase is the second part of the exponential growth phase. It is called the exponential growth phase. And this is when English holly actually has been shown to be fit very closely in models to an exponential growth, which is quite concerning because it has, when you have an exponential growth of the plant itself, the trunk, the tree will be growing, but also the canopy cover is extending out further. And I'll just quickly highlight where that is there, along the curve. So continued research from Stokes and colleague in 2014 did a model over 35 years using data analysis that he got in the field, where after a year, plant cover was 0.2%, 10 years reached 2%, 25 years, 15%, and 35 years up to 50% or more, which is a very quick exponential growth rate. Another thing that's concerning in combination with that is that English holly, once it reaches the age of 10, about 10 or older, it has a close to zero mortality rate. As mentioned, English holly, I found we know that they can at least reach 250 years in age, but they may be able to grow older as well. So in combination with soil chemistry change